Hey there everyone, welcome to another video of Engineering Pritam. And with this video, I am going to start a new series where we will try to build several different kinematic links that I really love to see online. And one such is the following that we're going to right now build it here. And if you like it, you can download the step file from the link down below. So here what is happening is there are two different kind of mechanism. One is Scotch Yoke and another one is single slider crankchain. Basically they are, if somebody is from mechanical, they are kind of inversion of each other. So here we go. Here they both look like, and you can see the motion of both these are not same. And the reason here is quite clear or quite simple. You can see in case of Scotch Yoke, it is only moving to and fro. However, when we talk about single slider, here you will see the motion is not pure sinusoidal, because as we know in case of single slider, the forward stroke is not equal to reverse stroke. Well, in case of Scotch Yoke, it is equal. Alright, so I'm not going to go much in deeper. Let's try build both and let's keep them side by side. And I really would like to enjoy building both, and we will see how they both will work in same fashion. Alright, so in order to build these, I chose my favorite CAD tool, of course Academic Edition, to build this. So let's quickly click here on new, and then I'm gonna choose assembly. So if you also want to follow with me along, want to understand how to build assembly with proper linkage so that you can also perform kinematic analysis like this, you can follow me along. So here I'm gonna uncheck this use default template, and I'm gonna say Scotch versus single. Maybe that would be enough. And now let's click OK. And probably I need to customize this, the configuration file, because I am not from a country where inch pound system is being used. So let me choose millimeter Newton second, assembly design with absolute accuracy. Alright, so now let's create our first component. I prefer to create assembly first, and then we can add component. So let's add base first. So I'm gonna add base, and again here let's copy from existing and then leave component unplaced. Now I'm gonna open this base separately, and here let's build it. Let's take a sheet, and I'm gonna make it like 300 by 500. Or let's make it even bigger. I'm gonna make it like 600, and this one has 1000. And now let's make it symmetric and give it a thickness of 20 mm. And let's add chamfer. I don't know why they do not give chamfer of style like all around. I mean, just like what we have in case of round. Okay, so what I am doing here is, instead of making a single left click, I am making right click. That's how you get option of advanced selection. That's how in 3-click I was able to provide chamfer in all these sites. If you want me to cover this particular topic in detail, do let me know, or maybe I can put the video that I have created in my previous channel in the description of this video, so you understand the concept of advanced selection, and that's how we save time, Alright, so let me also create a working directory, and I'm gonna say Kinematic, and let's save it here. I'm gonna also save my assembly in the same directory, and hope that if I open it, I'm gonna open my working directory. Fine. Let's close this. Now I'm gonna assemble this. So let's click here on edit definition. I do not want separate window. I just want main window. And now let's install it or assemble it as default. So I'm gonna choose current constraint as default, and now it should be fully constrained. Yep, it is. Sometime because of bug you may not see, but it was fully constrained as we have chosen default as constraint. Alright, so is this the way we wanted it to be? Yeah, probably. Now what I'm gonna do next is I am going to make some pin joint, and for that I'm gonna create hole here. Again, I need to activate this part. So by activating this part, you do not need to explicitly open the part. In this way you can actually enter inside. And now, yeah, let's add two holes. Probably I'm gonna use offset reference collector, and I'm gonna give it a distance like I think I'm gonna make it at 50 mm offset, and this way it can be like 250. Oh, I think I have given depth as 250, so let's give it 250. And now I'm gonna go simple, or maybe, I don't know, maybe drilled. Yeah, let's go with drilled. And I'm gonna go with 8 by 1 mm pitch, and let's further customize it. I'm gonna say through all, and for the depth of thread also should be through all, and I am getting this option here. Now I can also add countersink at exit. Okay, and let's make it, so it was 8, so I'm gonna make it 9. So in a way it is kind of 0.5 chamfer. And I'm gonna also add countersink on the top so that I can also add one chamfer here. So let's also make this 9. So in a way I'm adding chamfer to the both end of hole. All right, so here we can see M8 into 1 and then chamfer being added to the both side. Now let me expand this, and now I'm gonna mirror this, and now I'm gonna face some problem here. So let me actually disable these planes so that I do not select by mistake the plane of assembly. Instead, I would like to select the plane of base, and here we also can see by hovering that I am selecting the correct plane, and there we have it. All right, so now again I'm gonna activate my assembly, and now probably I can unhide them back, the assembly plane. And I also do not want to see these annotation. Okay, now time came to create, I would say. Let me also show you in between. Now time now came to add these circular wheels, and probably I'm gonna also add these stripped bolt, I would say. So let's add strip bolt of probably the thread size should be 8. So let me again create another part. I'm gonna say this as stripper bolt. Let's click OK. All right, so let's add another part. I'm gonna click new, and I'm gonna say stripper bolt. All right, and of course I need to choose millimeter Newton second part solid with absolute accuracy, and let's build this bolt real quick. Probably I'm gonna use revolve. Let's take center line. Now plot head with of course undercut, and then again I'm gonna leave some area for threads, and here also I think I should add one undercut. Okay, so let me delete these segments. All right, so let's make this how much it should be. So let's make it 15, and I'm gonna give it a height of 8, and let's also try shift this a bit, and probably I can give this a distance of, this one needs to be 0.5, and I can actually make this equals this. Now I'm gonna make this particular one which is this as a little bit bigger, like 5. And now, oh, I don't understand why this got, now this one can be 8, this one of course will be then 7, and then again this one as 0.5, and let's make this height as 10, and this one as 15 or maybe 20. Yep, and actually let's make this 15. I'm gonna close this. Let's revolve it. Now again I'm gonna add few chamfers here. Let's make it 0.3, 0.3 here. Oh, everywhere? Yeah, probably that's a good move, I would say. Okay, but seems like it can't be everywhere. Here, here, and here, and here. Yeah, makes sense. And probably here. All right, now it looks nice. And let's also add extrude on the top. Let's make it Phillips style. Let's give it a distance of 1.5, and let's make it coincident. Okay, so I think I need to add a point here, then I can make coincident, and same goes to opposite side. Yeah, all right, so let's give it a depth of 2.5. Oh, I think I need to remove it, so let's click on remove material, Yep. And now I need to also build the thread. So let's go here on helical sweep, that you will find it somewhere here. Oh, here. And seems like volume helical sweep is way to go. Okay, so when you define the helix profile, let's click on sketch. Now I'm gonna define it, and it seems like I need to cover it. Let's me get a reference first. Oh, all right. So let's start it from here, and then of course I need to add center line. Now we also need to create section. So let's create section. All right. So in order to create metric thread, probably I need to make it like 60 degree. And okay, so this one was M8 into 1. So let me make it 1. Now let's click OK. And probably I also need to change the pitch to 1, probably 1.001. All right, so seems like we went a little bit off the tool vent, but no worry, we will fix it. So let's go back again here in references, and I'm gonna click on profile. Let's make it 3. Yeah, let's now have a look. All right, still I think I need to go a little bit more down here. So let's further make it 2.8. Let's see how it is. All right, so in 2.8, I think we are going up to here. This looks good. So our bolt is ready. Now I'm gonna save it, of course, in the same folder. Let's close this, and now I'm gonna press A to assemble, and let's assemble this stripper bolt, axis to axis, and let's go a little bit on it up, and now let's go more up actually. Now let's face to face. And that's why, you know, I have added chamfer on the both sides, so that there is no such interference, or because of some chips, there is an issue in bolting these parts. All right, so this one is bolted. Now I can actually use a reference pattern, and it will automatically recognize it. And I don't know why I do not see it. All right, so let's leave it actually. Or maybe, I don't know why it is not coming. It should come actually, or they might have removed, but no worry. We can actually mirror it. So let's mirror the component. Now we have installed it in both sides. Now this is how it looks. Maybe I can also make it. And let's also try to change the color here. Let's make these bolts as a little bit brown or bronze. I don't know which color it is. Yeah, it's brass actually. Now let's again go back to shading with edges, and maybe I can also make this plate aluminum. Of course it doesn't look that good, but when you go here in file and you click on render studio, you should be able to see. I don't know why it is not coming. Oh, it is loading actually. I hope it doesn't crash, or even if crash, then no worry. If I can click on cancel. Oh, come on. Let's wait for a while. Alright, so this is how it looks. Of course, we need to further improve it. Maybe I can change the scene here. But I don't know why I'm doing it right now. Because probably we need to do a lot right now with the part. And so far, we only have bolted. Okay, so there is... let me go here and click on feature. I forgot how much was this. Okay, this one is mirrored. How much was the length? 20 mm. So now we need to make wheel of 20 mm. So let's click on create, and I hope we will able to do that here. Wheel. And let's use these as... Okay, so let me again open it separately. Oh, seems like I copied everything here. Let me click on delete, and now here I'm gonna take this as plane, and let's make a circle of, for the timing I'm gonna make it 500, and yeah, probably I can also add hole directly here in. Let's make it 10, and the distance here is 175. Let's put it 175 for the time being. Alright, so the center hole here needs to be of 10 mm actually, because here we're going to use bolt. Let's make it 10. And probably, I guess we also need to reduce the size of it. So let's make it 300, and this extra, let's make it 130. Maybe I need to remove this because this one needs to be threaded probably. Yeah. So let's delete this one. Let's focus on these two. Now, let's click OK. Now this needs to be 19.5, or maybe I can make it 19.8 because 20 mm is the gap that we have provided. Now let's add something here. For example, I'm gonna add round. Let's make it 3 mm. I'm gonna select okay, this edge as well as this edge. Now just to improve look and feel, we can also add things the way we have seen in this picture like this. So we will try to add something here. So let's first of all add hole offset reference collector. I'm gonna choose these two. Let's make it 0. Of course, this need to be standard hole, and then let's go with ISO, and again here as well M6 into 1, and let's make it through hole. So okay, through all, and here also I'm gonna make it through thread, or maybe it is not needed through all, so I'm gonna give it a depth of 15 would be good enough. And then here also through thread, and yeah, in the top I can add a countersunk. Here I'm gonna add again chamfer of 0.5 each side, so let's make it 7. Now let's click on OK. Now should we also add some kind of fancy feature? I don't know, maybe I will try to add something here, just like in this picture we have. Of course, I'm not going to create the exact one, just to go a little bit faster here, but I will definitely try to create something similar. Let's make this 170. So this one will be 10 degree, and then this one will be like 100. Now, okay, I can give it a distance that start from probably 30, and it ends. So I need this distance instead of this 17.3. I'm gonna choose these points, and then let's give it a distance of 110. Alright, so everything looks in constraint. Now let's copy, let's select and mirror. Now comes the interesting part. So of course I'm gonna remove the material, but now to make it look more 3D, we can add a little bit of taper here. So I can click on add taper, and now I'm gonna add this kind of taper, and let's reduce the depth actually. So I'm gonna make it like shallow depth, yeah, to 1.5 probably, and let's add more angle actually here, 80 degree. Yeah, 80 degree looks good, but we can reduce the taper then. 0.8. How about 0.8? Yeah, this looks good. Now let's close this, and I'm gonna also close datum plane for the timing, and let's also add round here. Probably I need to increase the value of round to make it, say, 15 probably here as well. Okay, that's look good. Now let's actually I'm gonna select all these features, both. Let's group them, and now I'm gonna go pattern, and let's make it axis pattern. Let's enable the axis display. Now I'm gonna select, and let's make it like 7 angular extent. Yep, now it looks a little bit better, and probably if we want, we can further make it like this, but let it be as it is. We do not need to copy everything. Yeah, I think it looks good. I'm gonna say wheel here, and let's close it, and let's now assemble it here. All right, so here we go. So this time what I'm gonna do next here is I am going to pick or create a pin joint, and the constraint here for the pin joint is it required an axis to axis connection, and then since pin only have 2 degrees of freedom, it can either rotate clockwise or counterclockwise, unlike cylinder joint, which also can go plus z and negative z. So that's not the case in case of pin joint. And now I'm gonna also give it a distance, let's say 0.1, because if you remember, we have made the thickness of this wheel. So I'm gonna give it a 0.1 offset from each side. So let me rotate it first. So it is working as expected, and let me show you the reason why I made it 0.1 or 19.8. Let's go here and view, section view, planar. Probably I can select this and can move it like this actually. All right, so if now I see it from this side, you will see that there is a gap upside also a little bit, and then in the bottom also. I do not remember actually how much I provided, but you see how much it was actually. So let's quickly measure this distance from here to here, 20.5. All right, so since we have added this undercut, so that's why. So let's make it actually 19.5. Control Z. Now it will be 20. Yep. Let's close this. And now if I refresh, here now you're gonna see both sides the clearance is 0.1. All right. So that's why I made this wheel as 19.8, and then this stripper bolt have gap of 20. So 0.2 is a clearance that I kept so that the wheel can rotate freely. Of course, the flatness of this wheel needs to be awesome, and of course it will be, because I don't know, I'm just thinking of this wheel to be milled or machined instead of injection molded or something else. All right, so we now need to create another stripper bolt that will sit here. Yeah, and then on the top of it, we need to add these bushes. So let's again, let's get back to the work. And before that, actually, what I'm gonna do next here is I am going to assemble another wheel. So this one also will be pin joint, and let's make it cylinder to cylinder. And then of course from face to the face here. And again here also I'm gonna give it a distance of 0.1. Let's click OK. And now here you're gonna see both our wheel are working as expected. So for those who are wondering like how I am, simulating this kinematic analysis, you need to press Control and Alt, and then you need to, use proper joint and connection the way we used here, pin joint, and simply press your left mouse button, and then you can play with your connection. All right, so now the next thing here I'm gonna do is I am going to add another stripper bolt here and here. So again, part can be common, and then of course we need a bush. So let me actually open this stripper bolt, and let's create a copy of it, and I'm gonna say stripper bolt, and this one will be a little bit smaller. So let's make it M6, and now let's close this, and we can open another stripper bolt now. All right, so let me quickly go here and revolve. Now we need to reduce the dimension here. So for M6, this one needs to be 6. So let's make it 6. This one needs to be 5. And what else? This one, I'm gonna make it like 4. This one can be 5. And this one can be 13. All right, so I am creating this non-standard stripper bolt. So you are thinking of if there are standard bolts. I think yes, there are so many websites or companies like Mizumi, they make these kind of bolt. Of course, since this is kind of can come in any size or length, so you will find ton of customization there as well. All right, so seems like we also need to reduce the depth here. Let's make it 2. I'm gonna keep it as it is just for the sake of time. And now here, let's assemble that. And seems like still we need to do something more, which is regarding this volume helical sweep? Oh, it seems like it got automatically maintained. And the pitch here, what we have taken is 1, and that's okay. We should have chosen, in case of 8, as a pitch 1.25, since that is the coarse pitch, but let's keep it as it is. Now I'm gonna click on assemble, and let's assemble this M6 bolt, and let's quickly do again in the same way, axis to axis, and still trying to take, base of it, maybe like this. Yeah. And now here, now I'm gonna properly make it coincident, and let's make sure that this is not coming out. Let's hide the base plate. We see if the bolt is installed correctly. One more thing I can do is I can actually enable the plane display, and let's see here the section, because I forgot actually how much was the depth of the hole. Okay, so let's also go and change it to wireframe, and seems like the depth of hole is high than the depth of bolt, which makes sense, and I think it looks good. Now again I can stop this sectional view, and let's also bring this plate back. Now let's do the same with here as well. Model, assemble, stripper bolt, and again I'm gonna go select base, and let's choose this base, coarse, axis, and then there's another axis. Seems like we have done something wrong here, huh? Oh, so this is distance. Let's make it coincident. All right, so that's how we assembled this another stripper bolt here, and it's worked perfectly fine. Let's add a bush here. Okay, a bush. Let me also calculate how much is the distance we have available for the bush. All right, so 20. So I'm gonna close this, and let's go here, file, new. I'm gonna name it as bush, and check default template, and then yeah, millimeter Newton second with absolute accuracy. And let's go here, extrude, circle, to circle. Inner one seems to need to be 8, and then outer one can be 10, or we will see, we always can change it. Now this needs to be 19.8. all right, so let's again save it, view, close, and now I'm gonna again disable all these, and time now came to assemble this bush, and here we go. All right, so this bush can be a pin joint. Of course it needs to be pin joint. Yeah, so let's go here and make it pin joint. So axis to axis, and then of course flat to flat. Although the movement, I would say, is almost cannot be seen easily, but still let's do that, and probably I can also increase the dia now, because now I can see it how thin or thick it is. Let's make it 13. Now let's regenerate. Now I'm gonna add chamfer to the both side. Oh, why this is 0.33. Let's make it 3, and here also in the bottom. Now it's look good. Let's close this. Chamfer added, bush added. Let's do the same here as well. So again, I'm gonna go here and let's make it pin joint. So I am trying to mimic how it will be in actual. So that's why I am making it like this. Oh, I think we already have made axis to axis. Let's make it flat to flat. Let's give it a distance of 0.1. all right, so both the bushes are being added, and let's also convert them to brass. And the reason why I'm making bushes of brass, because it have got very good property of abrasion resistance. All right, so now just to make it look more stylish, maybe I can add chrome here to these wheels. I don't know how it look, but it for sure going to look a little bit different. Okay, now seems like we have made this much ready. Now time came to add a crankshaft, and seems like we also need to make this plate a little bit more wider. Let's make it 800. Hope that this will give us enough room to play. Alright, so what I'm gonna do next is I am going to create a bearing, not thrust bearing, but vertical bearing that help rod to glide. So let's build that. So for that I need to take few consideration, especially for the height. So I need to take the distance from here to here, the 19.2. So that should be the height. All right, so let's make the bearing now. Now let's also add circle, again another rectangle. Now let's start cutting it down. Alright, so this is the shape that we need, and probably also in the center we need to make it like this. Yeah, maybe we can make it square. I don't know, there are so many constraints that it is offering us to have. Let's not make any such, and let's make it equal. Now I'm gonna make it like 25 by 25, and we know already the height, so we can also give it height of 19.8. and now I actually completely forgot what was it. So it was extrude actually, and we can also define the total height here. Let's make it 60, and make this one as 10 at least. It should be from both sides, I guess. Yeah, and this one again, we can make it like 130 or even less, 100. Yep, 100 will be enough, and let's make it 12. Alright, so let's make it symmetric, and I'm gonna make it 25. Yeah, let's also unhide everything. Now I'm gonna add auto round, or maybe let's leave it. Chamfer is always easier to have. Let's increase the value to 1. Here also on the top, 1. All right, and yeah, here also we can give a chamfer. All right, so let me actually delete these, because then I guess I will be able to select the remaining as well. All right, so now I think I have added chamfer to all the sides, and let's click save. Now let's also add hole, although here the holes are not being added, but of course we need to add hole here, and let's make it drilled and counter bore. And let's also enable plane display so that we can properly choose the reference collectors also from the center. Let's make it 0 0. This one is 40 probably. And let's go here in shape, and if I'm thinking of if I add bolt of 6, so I'm gonna make it like 10.5. Of course I'm gonna reduce this. Let's make it 6.1. Or maybe what I can do is I can use IFX, Intelligent Fastener Extension, instead of manually putting bolt. Yeah, but for that, at least I need to have some kind of points. So let's add point actually instead of, Alright, so let's again take offset reference collector. I'm gonna make it 0, and let's make this distance as 10. That's good enough. Now I'm gonna mirror this point to other side. Alright, now let's save and let's close. Okay, so it need to be like this plate, and now I'm gonna add bearing. Need to be exactly in the center, and for that either I can calculate the center, or even better, I can create a plane in this plate, enable plane display. So this kind of give me I would say better freedom. Yeah, I'm gonna make it parallel, and then let's also mirror it. Click on view, close. yeah, so this now going to give me freedom. I mean, whenever I'm gonna make any change, it will automatically get shifted, or even let's say I am reducing it somewhere, the both bearing will always be aligned. Now let's go assemble, click on bearing. I'm gonna choose base to base because this one needs to be, this one needs to have 0 degree of freedom, so I'm not going to make it move freely. Now let's choose this plane and a newly created one. Let's make it coincident. And now how much distance I want. Probably I should have also considered center, but it's all right. Yeah, I'm gonna choose base right, and let's make it 450. It's still going out. 300. Yeah, 300 looks good, but seems like I still need to increase the width of plate. Yep, let's make it 400. Or maybe what I can do here is, this is very important, guys, like how we are creating these construction geometry, because if you have planned it properly, you do not need to do too much of thing. All right, so let's make it 100. I don't know, it's for the time being, let's make it 100. Now if I have done this properly, so here you can see both these holes are updated, and here also in just refresh, it already went here this side. That's how I am trying to create space between both. And now I can actually reduce this to 350. Now let me mirror this bearing as well. Perfectly fine to mirror this mirror component. Yeah, I'm gonna keep it dependent, and let's use assembly. There we have it. Now I also need one more bearing, especially in case of Scotch Yoke mechanism. So let's add one more bearing. This time I'm gonna manually install it, and I'm gonna make it parallel. Let's go coincident. I need to flip. I don't know why sometimes this happens. So let's go coincident. Now probably I can give it a distance constraint from here. Let's give it how much? 50? Of course, negative. Alright, so now still there is one more constraint that got left, is this one. And now we have fully constrained it. So when it comes to Scotch Yoke, I think we are almost done. All I need to do here is I need to add connecting rod here. And let's create this one first. Alright. And I'm gonna also add some kind of different color here. And probably I'm gonna go with steel. Yeah, steel for this, and this. And if I change it to shading, okay, it looks like this. Maybe I can further improve the way it looks here. Probably I need to change some settings. Yeah, especially this one. All right, so seems like these settings are already pretty high. Okay, now let's build this connecting rod. I'm just thinking of how I'm gonna build this. All right, so let's build this shape first, and then I'm gonna add. So I'm gonna say connecting rod in Scotch Yoke, of course, millimeter Newton second with absolute accuracy. And let's plot this. Probably here I need to think of how much the width needs to be and how much the height needs to be. And of course I also need to add here the slot. Let's also make it circle, and let's delete the segments. Now of course we're going to make the necessary changes as needed. For the time being I do not remember all these values, so I'm gonna make it like how much it was, 19. Let's keep it for the time being. Now I'm gonna go back and probably I'm gonna measure. So let's close all the display here, and dial here is 13. Okay, and then probably it was 19.8, so let's make it 19.8. Oh no, I mean it can go even up. All right, so the bearing also needs to be 19.8. all right, so it's not like 19.8 is the only one. We can also make it 19, but let's go with 19.5. And we saw this was 13. 13 was the dia actually. Let's make it 6.5. I'm hoping that this was the case here actually. Dia. Yeah, 6.5. Now let's go back here and let's further modify it. So I think it can be 200. Oh no, not 20 of course. 200, and the thickness can be 30. I mean, of course we can also make it exactly like this. So if I remember the inner one, okay, so let's actually do that. Okay, so this is 6.5, and then if we subtract 30, then that's going to be 17, and then if we divide 17 by 2, so that will be 8.5. So probably just thinking of, we also need to add distance here. Okay, I'm gonna make it 160. So if this is 160 and we specifically or literally want same, so we need to add 17 both sides. So this needs to be 177. We made it 200. Like, okay, let's make it 177, and now it is exactly the same size. And then probably can also add roundness here. I am forgetting how much was the length. 30. So let's make it 15. All right, now let's add the remaining part, and that should be easy. All right, and probably I also can make it thickness. Here is 25. Let's make it 250, and probably we can also adjust it as needed later. This needs to be like 350, and let's make the depth to next. Or maybe I'm gonna say yeah, of course next, but why it is not coming? Okay, to reference, and this is the reference. Now let's also add chamfer. All right, chamfer looks quite good. All right, it seems like we have added chamfer all around. Now all right, before chamfer, I think if I add round here, then that would be even awesome. Let's make it a round of 10 mm. Yeah, can delete this one actually. Now if I add chamfer, it will go like this. Yep, that's exactly what I wanted. And yeah, so let's save this part and close this. Now the interesting part came, like how we going to assemble it. So for that, first of all, let's add it here. There will be multiple joints that we need to create. I'm also thinking of okay, so this side is long, this side is short. First of all, let me add cylinder joint here. Now I'm going to select this side and probably the top side. Okay, so it needs axis to axis alignment, huh? Okay, for that probably I need to create one axis actually. So for the time being, I'm going to keep it like cancel. Let's create an axis. And of course this axis can be here and the center. So let's make center as 0, and let's make the distance also as 0. Now let's click OK. Now same I need to do with another part, which is our rod, and of course we need to increase the length of it as well. So let's increase the length actually first. I'm gonna make it like 500. All right, so let's also plot an axis here, and let me actually see. Yeah, we can actually rotate it as well. So let me plot an axis. Let's make it 0. This one also is 0. Let's click OK. Yeah. Now let's close this. Now I'm gonna enable this or bring this connecting rod, but let's also enable the axis display. Now here I'm gonna choose cylinder as a joint, and then I'm gonna choose this axis, and then here also this axis. Now this is constrained. Seems like we also should add a line here and a point here. All right. So first of all, let me actually make it inside. Oh, seems like I should have pin joint, actually not, or even I could have used something else. Yeah, instead of cylinder, I should have used slider actually. So this is wrong. I'm gonna choose slider. Now I'm gonna do like axis alignment. Component, yep. Assembly, yep. And this should be coincident, right? And rotation also need to be locked. Yeah, now it is the way it should be. It will not rotate, it will only slide. And same, I guess, here we need to do. So this will rotate, but this will do this kind of motion, right? So for this, I think what should I do is I should create the same axis. Probably I can see if I can also enable point. I'm gonna say this point. Oh, this point should be automatically created, but no. Okay, so I don't know. I mean, there should be something that could be helpful. Okay, so this can be helpful. I'm gonna say this axis pass through this. So where is new axis? I do not see it. So axis. So let's make it 0, and this one also has 0. Let's again click on save and then view, close. So seems like we created axis in opposite direction. Let's make it up. And I also need to see the gap. So there shouldn't be any gap. I can, for the time being, remove this bolt, and I can see now here the distance. Okay, so this need to be 0.3 less. So I'm gonna make it 0.3 less. Okay, so instead of 19.5, it would be 19.2. Okay, so now I'm gonna press Control R, Control Z, I guess. Yeah, Control Z. Now let's close this and let's create a point on this plane, and let's close this. I'm gonna display point as well as axis. Let's actually I think I have chosen this one as wrong. So all right, now it's look good. Now let's again apply slider joint here, and for that again I'm gonna go assemble and then new set, and then I'm gonna keep slider. Now here also I'm gonna go axis to axis. Now the next here what I'm gonna do is I am going for slot joint. Now here I need to choose this point and then this axis, and seems like axis cannot take path, so I actually need to draw a path here. So in order to draw path, I need to go back, and here I need to go and plot a sketch. So sketch can be considered as a path. Now go back again. Connecting rod, which is already do not have complete degree of freedom. Let's go new set and let's go slot. Now I'm gonna choose the connecting rod and the point, and now it is properly constrained. Now if I rotate this, it will behave like this, but the slot width is not enough. So let me increase the slot width here. Let's make it like, I do not realize actually what was the width of it. Let's make it this much, and I don't know why it is failing. It shouldn't fail actually. Why it is failing? Oh, so here is the problem. Let's make it 317. So instead of making it 317, so this is wrong practice here. I think I have adopted. So I'm gonna select this part and this part. I'm gonna say distance, and let's keep it 8.5. So now if I make any changes next time, let's say if I'm gonna make it 320, it will automatically update the parent. So this is very important to understand parent-child relationship. All right, so I'm hoping that this time now, the Scotch Yoke should be able to cover the entire portion. And let me see here. And seems like yes, that is the case. All right, now let's also see the another one, which is the single slider crankchain. And here seems we need to make two parts. One would be connecting rod and piston. So let me make it a little bit large. Here again I can see it's not going till the point it should go. Let's make it 550 or maybe 600, and we actually can reduce this one to 200. I'm gonna press Ctrl and Z, and let's come out of it. Again, I'm gonna see if I can really. Oh, so this one also need to be increased to 250. Now I think it should be working perfectly fine. Oh, still at 250 it is going out. 300. So by changing this filter to feature, it really gives us opportunity to modify the part directly in assembly mode. Oh my god, still it is going out. So again, I need to increase the height to probably 350. Now it shouldn't have any problem. Now let's add connecting rod and piston. So here also we need to make some adjustment based on the thickness of this part. Okay, so this is 19.2. Now let's go here. I'm gonna change back to geometry so that we can select the part. Now, okay, so let's select this, extrude, edit. Let's delete this actually. It's not needed. Now I need to reduce this 19.8. Let's click OK, and then OK. Now I think in terms of height it looks good. Yeah, so it was actually 19.3, but it's okay, I'm keeping some clearance here. Okay, now let's create the connecting rod for this one, and this one seems a little bit more interesting. It needs to be like this, and then here like this. So I'm thinking of how it needs to be. Probably I can take this and then I'm gonna copy this. I'm gonna say connecting rod and then slider, or maybe single. You can give it any name. Name doesn't matter. All right. So now let's delete everything here. $25. Now let's make it like 350 for the time being, and then both side I'm gonna make it like this, or not like this but even beyond. And then let's also delete this and here as well. Now let me delete these person. Okay, all right, so this is also something that needed to be deleted. Okay, now I'm gonna add another circle here and here as well, and probably I'm gonna dia, and let's make it 50, and I'm gonna also like keep center to center distance. Yeah, let's keep it 350. So this is kind of center to center distance, because if you see here, it starts from this side and then end toward this side. All right, and this is 50, which is perfectly fine. And I also would like to see how much this one is. So for the time being, I'm gonna make it 15. Oh yeah, so they are kind of linked. All right, so for the time being, let's keep it as it is, and I'm assuming that this is 33. Okay, so I'm not gonna keep this one as dimension, so let's delete this. Let's control this, make it 25, and yeah, so let's click OK. And here I'm gonna give it like 19.5 both side. Now if you see here at one end, we need to give slot for another side to get connected. So I'm gonna do the same here. I'm gonna do extrude, and let's make it symmetric and remove material, and seems like it is okay. Now let's keep all the thing as it is, and then we will make change on a move while assembling it. All right, so of course I have created a copy of it, but I meshed with the Scotch one. Probably what I can do here is, oh, I don't even have option. All right, so I will have to like disconnect everything here. So there is a good thing and bad news. So bad news was I accidentally modified this one, and the good news is I also have created a saved as copy of it. So all I need to do, I need to reassemble some of these parts. So that's perfectly fine. Of course, I need to change the mechanism here, and I'm gonna go pin joint here and like this, but in opposite direction. Yeah, I don't know why this jumped off. Yep, let's select the base, this one, and component. All right, so I don't know why this is not going down. It should actually go down perfectly fine. I need to make some adjustment here, I guess. Component. Oh, that's why. Now it is fine. Yep, so this is my pin joint like this. Now let me first of all reassemble the part that I accidentally deleted. So it should be called single now. And yeah, we need to go with slider. Again, we will have to do everything. Yeah, we don't have any other option. Okay, rotation, I can avoid it by giving him either this one or maybe this one is good enough. Now, let's again new set, and this time slot, and oh, I made a mistake now, seems like. Yep. Alright, so let's again go here, axis alignment. Okay, so axis alignment is good. This transactional or rotation is bad. Let's delete this first, and now I'm gonna rotate this like this. Now let's component and assembly. Now this is fixed. Now let's fix the remaining part by selecting this, and oh, I need to enable point display, yeah, and this point, and there you have it. Okay, so the last part of this puzzle or this thing is this portion which would act as a piston. So let me create this. Probably I'm gonna copy this. This time I need to be careful. Save as, and I'm gonna literally call it piston, and I will take care of this time. Like, I'm not going to edit this one. Instead, I'm gonna edit piston. So I need to make a male part here now. So let me actually go back here in extrude, and can simply create two rectangle. Yeah, I think one would be enough, and then probably I'm gonna delete this. Yeah, but before that I also need to think about the thickness. The thickness need to be lesser than this, so let's make it 6.05, and then of course I need to delete these line segment, this, of course this, and there will be some overlap here as well. Yep. Yeah. Now let's do that, and I'm gonna also mirror it, and then let's enable the plane display mirror. Oh no, I don't know why this happened, but okay. So let's mirror. Should not be the case actually. Why this is happening like this? I don't know. So let me actually go back here, and yeah, instead of doing like this, simply select this and then mirror. Yeah. So this is the correct mirror. I don't know why this was not the case. Now let's go back. I'm gonna save it, and then let's close it. And I also need to think about making it slider. Okay, so here we already have this. Now I need to have similar kind of slider on my piston on this side. So let's have it actually. Shouldn't be tough. So let's add axis. And I'm gonna say, yeah, axis, and let's offset reference. I'm gonna give this as 1, and of course this one as 1. So I'm gonna make it like 0 and 0. Yep. Okay, and what else? Let's click on view, close. Now I'm gonna make it like this. assemble, thumbnail, and now connecting rod. What should it call? It should be called piston. Okay. Now, one thing we need to do is we need to assemble piston first, then connecting rod. For that, I think I need to do like this. And now, oh no, not like this, but I need to move the piston up. Now I need to assemble it. So let's first of all enable the axis display so that we can go and choose slider. So the reason why we are creating axis is because we have already provided chamfer to our parts. So when we add chamfer, it is difficult to get, edge to edge. So that's why we are creating these extra axes. Now let's go on the top and I'm gonna select slider, and now again same. And in order to stop rotation, again here also I think I need to kind of flip it. So I don't know why this is not giving me option to flip. So let's remove it first, and I need to manually flip it. Now let's fix it, and let's control the rotation by this. All right, so this is kind of assembled. Now we need to assemble this part. So we already have assembled this connection. Now the second one here is this time not the slot but cylinder. So let's add new set and select cylinder joint, and now select axis to axis. Oh, I don't know why this is not giving me option. Okay, so I don't know what it is thinking of. Okay, so let me click on cancel. Oh, so again, because of the name, I got confused. I need to move it up. Now it is good. Let's go here, edit definition, and we already have defined one pin. And here I'm gonna go new set, and now here let's go for cylinder. So let's select this, and there we have it. Let's click OK. And now if I try to rotate this one also move as expected. Now the only thing here I need to do is I need to increase the width a little bit more of this plate. Let's make it like 900 or maybe 850, and let's go back. Now one more thing here, what I can do is I can also reduce the length of this connecting rod by 50 mm. Let's press Ctrl and Z. Again, I think I need to go back to main assembly, and again press Ctrl and Z. Everything now back in place, and now let's try rotating it. Still, it is kind of going inside. So let me again push these bearing a little bit back. Okay, yeah, 350. So let's make it 400. I'm just hoping, that especially in this case of Scotch Yoke, it is not going outside. Since I have mirrored it, so sometimes it can be a problem. But let's increase the length of it. But generally, if this would be like being created practically, I would have considered instead, I can reduce the distance instead of increasing the length of it to save material. But just here we are trying to simulate this, therefore I am not too worried. Okay, now this one also looks good, like not going outside. In fact, what I can do here in this case is I don't think so that I need opposite side like this. I can actually edit this part. Alright, so now I cannot identify which part was which side. Okay, so yeah, now I got it. So I can make it like this. Let's delete this part, and let's make it 350. So I'm just making a little bit shortcut here, but still it looks good. Now again I'm gonna press Ctrl and Z to regenerate, and now yeah, it is perfectly single slider crank chain mechanism, and this one is Scotch Yoke, and yeah, it is going a little bit out. So I can increase the length of it. So let's make this a little bit more. I don't know why the length is not coming. Okay, now it is. Let's make it 650, and this one is 400. All right, so now let's close this, and in order to automate this, I can add motor in both the cases. Okay, so let's go here, application. First of all, let me save it actually, and probably I'm gonna also attach both these models in the description of this video. Now let's go application and mechanism. Now I'm gonna add motor, and I can add to this axis. Yeah, and then I'm gonna say angular velocity, or yeah, that's how, you know, the constant velocity looks good. And then I'm gonna say ramp. All right, so the ramp give us option to, you know, define the value of a and b, or even let's go with angular positions. So I'm gonna say initially the speed was 0, and then it accelerate at certain speed. Now it became at 10 degree per second square, or maybe I can make it like 30. Now if I want to see the graph, it should look like this. All right, so same setting I'm gonna implement in another one, and yeah, this looks good, 0 and 30. And let me actually play it. Mechanism analysis and run. Oh, it went really fast. Probably I need to increase the frame rate here. Let's make it 60, and now run it. All right, so it looks good, but still it is running pretty fast. So let me again go back here, and probably I'm gonna make it like 15, so that at least I can see it. Same I'm gonna do with this one. Let's go servo. Let's attach here again ramp, and then here I can define like 15. Let's click OK. Now again here as well, I'm gonna do the same. Let's do analysis, and or maybe quick mechanism analysis. Yeah, here also I'm gonna make it like 60 frames per second. Oh, seems like we are playing with both motors now. So here we have option to add both, and we can define from and to. So we also have option to, you know, set up these values manually. So I'm gonna say like 100 seconds it is going to end. Here also 100 seconds. Now let's click on run. All right, one is moving slow, another one is moving fast. What is the case? I'm gonna make it like 100. Oh, I think here I have set angular acceleration, and in one case I have set angular velocity. So that's why it is going pretty fast, and then this one is going pretty slow. So these all are the things that we need to take care of. So let's go here in motor 1 properties, and let's see here. This is angular velocity ramp, and this one is angular position. So seems like we should select angular position, and probably I can make it like 30 degree per second. I don't know if still it looks slow. Let's make it 50. Now let's go with other motor as well, and let's make it 50. So what now it will do is the motor will start from 0, and then it will go more naturally. All right, so let me make it completely normal. And finally, this is how it looks, guys. I'm gonna make it like even more. I'm gonna give it more space here, or even there is an option of go full screen. Now I'm gonna go mechanism analysis. Let's make frame 60 frame per second and end time 100. And let's start. I also would like to make it like, you know, look same. So let me make it like this. All right, so both of them are almost at same position. I can also define this as my initial snapshot. So let's take this as, you know, snapshot. I don't know why this option is not coming. Okay, let's click on run. Okay, so seems like both are running in opposite direction. So I also need to fix the direction of it. Okay, so let's fix the direction of the motor. Okay, so again, I need to go away from full screen, and let's select the motor and let's flip direction. Yeah. And seems like we also should define snapshot. I don't know why I'm not able to see that option. Okay, so again, I'm gonna click here on mechanism analysis, and I don't know why I'm not seeing the option of snapshot. Okay, so I can create snapshot. All right, and here, let me make it actually straight. This one also is straight. Now I can take snapshot. Snapshot, create a snapshot. Yes, I want to create a snapshot. I don't know why I'm not able to do that. But let's keep it simple because it already have taken so much of time to create these models. And of course, you're going to see these models. I'm going to attach it in the description of this video. Now let's go here, analysis. And I'm going to do simple kinematic analysis here in this case. Okay, so again, application, mechanism. Okay, so here we have mechanism analysis. And then I'm gonna again make it 100, and then let's make this one at 60, and let's click on run. So both these mechanisms now are in same direction, so that's again great. And now we have got this analysis definition. So once this kinematic of analysis is completed, we can click on OK, and now I can play with it. So here I have got the playback, and then I can see it running. So again, going to process frame by frame, and there we have it. Now I can see it, and I can even go full screen. Now I can play, can go slow, I can make it fast, and there we have it. Scotch Yoke plus single slider in same board. So Scotch Yoke on the top and single slider on the bottom. I literally have invested, I do not remember, around more than 2 hours to build this project. You can also try and build it along. I mean, if you want to create these kind of connection, then this definitely required some practice, and the only to perfect your skill in PTC Creo is to practice. If you do not have, then I have shown like how one can get academic version of PTC Creo that also have got complete capability. If you do not want to use it commercially like me, then you can use it to build something, to learn something. And I'm gonna also add the video link of that installation process in the description of this video. The good thing about PTC Creo is that it is completely free, so you do not need to pay even $50, like for example in case of SolidWorks. So it's great, and this is one of the top tier software for mechanical designers, especially in commercial application. So from that perspective also, you're going to learn something really valuable. So that's all guys from my side in this video. Hope that you find this video helpful and informational. Please subscribe to Engineering Pritam, as we're not only going to make these kind of design tutorial in this channel, but you're also going to see so many other engineering topic, be it project management or other CAD modeling software. Especially I am covering FreeCAD series right now, which is very close to my heart because FreeCAD is one of very powerful software that comes for absolutely free. Even you can use it for commercially, so we should support them by downloading it. So I do not want to take any more time. Thank you so much for watching. And as you know, my previous channel got banned, and this channel is brand new or very new. So please support us by subscribing to Engineering Pritam, so that we can again bounce back and reach to the same level or beyond with your support. So let's catch each other in one session of the video. Till then, you take care and bye-bye.